Good evening, everybody. Today we're going to be talking about gas laws, pressure, volume, and temperature, and what they have to do with the gases. As you remember, this week we went more into states of matter and how when we change the state of matter, it affects density, and it is caused by the energy of the particles gaining or losing energy. And so we're going to expand that and just talk about gases and figure out what pressure, volume, and temperature all have to do with gases. So there's a few questions that we're going to open with. Have you ever watched a hot air balloon, shaken a soda bottle and had it spray all over you, or eaten a nice fluffy cake? So if you answered yes to any of these three questions, then you have been a part of gases that are expanding or contracting due to pressure, volume, or temperature. So this is what this slide is talking about. Now, anything that's in red, I want you to write that down for your notes. So hopefully you didn't write the first two slides because you didn't have to. So basically we can predict the behavior of gases based on these three properties. And when you get to chemistry class, they're going to give you an extra one to also think about. But for right now, these are the three that we're going to talk about. So, pressure is the force that the gas exerts on a given area of the container in which it's contained. And when we write pressure, we're going to use the units pascals, and that's abbreviated PA. Sometimes we'll also use atmospheres, which will be abbreviated ATM. So either one is the abbreviation for pressure. Now, here's an example. So we said pressure is the force that the gas exerts on a container. So a container can really be anything. So if you've ever put air in a tire, then the tire is your container, and the more air you put in it, the more pressure it's going to have, which is why you have a little pressure gauge, whether you're putting air in a bike tire, in a basketball, in a car tire. You have that little pressure gauge on your air pump, and it tells you when the tire is full. If you don't have a pressure gauge, usually you just use your hand. And when it feels like it's really full and it's not pushing down when you put your hand on it, then you stop putting air in it. Because if you keep on putting air in it, what's going to happen? We all know if you keep putting air into something that's already full, then it's going to eventually explode because there's too much pressure. So we all know kind of what that's talking about. Now, the next thing that can affect our gases is volume. So we've already talked about volume a lot. Volume is the space inside of the container that's holding the gas. So if we have volume of a liquid, how much space does that liquid take up? Volume of a solid, how much the space does the solid take up? So now we have volume of gases, so we're wondering how much space inside of a container that the gas takes up. So if the container is our classroom, if someone sprays air freshener in the class and the door is closed, then the classroom is our container. So that air freshener can spread out as far as it needs to, but it can't leave our classroom because the doors and windows are closed. So we know that gases will fill up as much area as they can. The particles will just keep spreading out until they can't go any further. So like we already said, a container can be anything. It can be a 2-liter bottle. It can be a can. It can be the gas tank in your car. It can be anything. Okay, so we're not just talking about a box or a cylinder. We can be talking about anything you can think of that a gas could be in is a container. All right. Now the last thing that can affect gases is temperature. So we know from our lab this week or last week, depending on when you're doing these notes, we did a lab on temperature and how temperature is measuring the amount of energy that the particles have. So if we have a high temperature, then generally that means that the object is warm or hot, but it also means that the particles are moving a lot. They're not vibrating in place like a solid would be. They're actually bouncing around. Now, we know some things have a higher melting point and a higher boiling point than others. So we could have a solid, let's say we could have a solid cube of metal, like iron or steel. And that could be a very hot material. We can warm it up. It could be really hot, but it's still a solid. Okay? But then we know if we warm ice up to that same temperature, it's not going to be solid anymore. It's going to be a liquid or maybe even a gas. So things have different melting points. That's one of their physical properties. But that's why we're not focusing on how hot something is. We're focusing on how fast the particles are moving. Okay? Now, an example of this is that water freezes at 0 degrees Celsius, which is 32 degrees Fahrenheit. But alcohol, like rubbing alcohol or the alcohol that you find in some drinks, it doesn't freeze at 0 degrees Celsius. So we can't expect that just because we can make water into ice at 0 degrees, we can't make ice cubes out of alcohol at that temperature. Okay? So just keep that in mind. All right, now there are 3 laws when we talk about gases. And the laws just explain how pressure, volume, and temperature relate to each other. So it's kind of like a law of the government, right? If you rob a bank, you will spend, let's say, 10 years in prison. Okay? I don't know that that's true. But the law is telling you the relationship between the crime you commit and the amount of time you spend in jail, right? So the same thing happens here. When we talk about our gas laws, we're going to talk about the relationship between the volume of the gas and the pressure of the gas, or the volume of the gas and the temperature of the gas, or the relationship between all 3 of those. So that's what we're going to be unpacking next week. Now, the first gas law is Boyle's law, and it's named after a guy named Charles Boyle, and he studied pressure and volume of gases in the 1600s. So a long time ago, over 400 years ago. So this has been accepted for 400 years. If there was something wrong with it, they probably would have figured it out by now. So we can understand that what he said about gases has been proven over and over and over to be true, which is why they're calling it a law. Now, Boyle determined, or he noticed when he did experiments, when he tested things out, he noticed that when the pressure of a gas increased, the volume decreased. Or when the volume of a gas increased, the pressure of that gas decreased. So basically, think about it this way. If you have a jar of oxygen and the lid is closed, there's going to be a little bit of pressure inside the jar because the gas cannot escape. It's locked into that jar while the lid is on. If we open the jar, we're expanding the volume, right? Because now the gas can go outside of the jar and go around in the room. So if we give them more space to move around, then the particles are not as close together. There's not as much pressure. All right, so think about our example of for Do Now this week, where we said that if Miss Poole's class had a party and Miss Fricano and Coach Maribel's class came in, and we had to close the door so that nobody else would come in, the pressure in the room would increase, because maybe Miss Poole's class only has 20 students in it. So they can move around a lot in the room. But let's say that now, after the other 2 classes come, there are 80 students. Well, now they can't move around as much. They're bumping into each other more. So there's more pressure. All right, so just always think about things. If it's hard to see the particles, think about a real world example. Think about filling a tire with air, or everybody having a party and how many people are there. Always think of something that can help you. Now this formula at the bottom, P1 times V1 equals P2 times V2, that is known as Boyle's law, because when we use that formula, it's going to show us exactly what the second bullet point said, which is if we have a pressure that increases, then we will see a volume that decreases, and vice versa. Okay, so make sure you get that written down. We're going to be practicing this in class. Now, Charles' law is named after a guy named Jacques Charles, and he studied the relationship between volume and temperature. So he didn't study pressure. He studied volume and temperature. And the turn of the 19th century, so that was around the year 1800. So that was 200 and something years ago. Now, this law determines that if the volume of a gas increases, the temperature does the same thing. It increases too. Or if the temperature decreases, the volume decreases. So in Charles' law, they're buddies. Okay, volume and temperature do the same thing. They're friends. Okay, in Boyle's law, they're enemies. Pressure and volume are enemies. They always do the opposite thing. So if you keep that in mind, then when you're working out math problems, you'll know whether or not your answer is right, because you'll know that it should be higher or lower or the same as the other variable that you have. Now the formula for Charles' law is V1, volume 1, divided by T1, T is for temperature, equals V2 divided by T2. So when we use this formula for a math problem, we're going to find that whatever volume does, if it increases from V1 to V2, temperature also is going to increase. If it decreases, temperature will also decrease. So that's what we mean when we say that they're buddies, they're friends, they do the same thing. Now there's one more gas law that we're going to talk about. There's actually many more gas laws in the world, but we only cover 3 in physical science. And it's called the combined gas law. And really all it does is it takes Boyle's law and Charles's law and puts them together. So if you ever have an opportunity where you need to calculate pressure, volume, and temperature, then we use the combined gas law so that we can get all 3 of those variables in the same formula. Okay? So the formula is P1 times V1 divided by T1 equals P2 times V2 divided by T2. And again, we're going to talk about all of these in class. We're going to do problems together, by ourselves, with a partner, all of the above. So you will be more than familiar with how to do these by the time we have our test next Friday. So if you have any questions, this was a quick lesson. Basically, I want you to notice things around you this week. Notice gases, notice different containers that have gases in them. Notice the pressure, okay? So next time you open a Coke bottle and it has that little whooshing sound when you first open it, that's the gas escaping that was trapped in the bottle. So I want you to think about stuff like that. That way when we're talking about it in class, it'll make sense to you, and you can even share your examples with the rest of the class when you realize that that's what we're talking about. All right, so have a good weekend, and these will be checked on Monday.